In this video, we're going to talk about fiber optic network cabling. So let's go ahead and get started. So the first thing that you need to know is that fiber optic network cabling has a glass or plastic fiber core that carries light. And this is what it looks like right here. So this is the glass or the plastic fiber core. And what happens is that we have light pulses. So our network interface card that's set up for these, it pulses light signals and it goes down through there. So it's not like our standard network cabling where we have a copper core with our twisted cables. Instead, this is moving light instead of electromagnetic signals. So it's entirely different. And so I think that's pretty cool. And so I'm going to go ahead and I'm going to go over here and I'm going to underline this so you can see this. And let me go ahead and get my pen tool out here. So it carries light. And this makes for some significant differences in terms of its bandwidth. So remember when we were looking at our twisted pair, the highest bandwidth that we saw was 10 gigabit per second. Well, if you look at fiber optic, up to 100 gigabit per second. So a 10 times increased possibility in speed. And when we're talking about 10 gigabit per second, that's really fast. Once we get up to 100 gigabit per second, that's lightning quick. Now, another benefit is that it can span much longer distances. So with our electrical signals, the signal is going to attenuate out of the cable and we're going to have EMI, we're going to have crosstalk, and so the signal is going to have signal degradation over time. Well, with light, we don't have that as much, and so it can go much longer distances. And while I'm talking about it, we'll go ahead and we'll point at it. So multi-mode fiber will go up to 6 miles and single mode fiber will go up to 40 miles. And so if you remember from our previous lecture when we were talking about twisted pair, we can only go 100 meters. And so we're looking at 100 meters and now we're comparing it to 6 miles or 40 miles. I mean, that's a drastic difference. Now, another huge benefit, and this is kind of a plus benefit in two factors. So the other benefit is that it's immune to EMI. And it doesn't emanate signals, because we're not dealing with electrical signals anymore. So when there's no EMI, there's no crosstalk, there's no signal degradation like there is with our twisted pair. And also, because we don't have EMI or crosstalk, it doesn't emanate any sort of the networking signal out of the wire. And so we don't have to worry about our security concerns like we do with the twisted pair. So that's another benefit of that. Now, there are two main types, and they are multi-mode fiber and single mode fiber, and we'll talk about those more on the next slide. So in terms of how they're used, multi-mode is typically used for shorter distances, so for local area networks and from building to building. Single mode fiber on the other side is more expensive than multi-mode, and it's used for longer distances, typically wide area networks. And you can see this will span 40 miles and this only spans 6 miles. And now I'm saying it only spans 6 miles, but if you think about it, this is probably more than good enough for a campus network if you want to set it up on a wide area network, because you're typically not going to have 6 miles between buildings. And now, if we compare this to our old type of cabling, our coaxial and our twisted pair, this will go much longer distances. So let's go ahead and let's see what the actual difference is between multi-mode and single mode. So with multi-mode, we have multi-bursts of light signals going back and forth, and they bounce off the core off the edges, which we see here. And so you're getting more than one burst of light and signals going at a time. Single mode is just one burst going straight down, and so one burst at a time, and that's the difference. Now, I don't know all the detailed differences of how it actually works and how these fiber optic networking cables work and how that works with this on a high level of detail. But from our perspective and what we need to know from a beginning perspective and just understanding how it works, this is how we need to know how it works. We don't need to know any more than this. So let's talk about why we would use fiber, and I already talked about it. The downside is that it's a lot more expensive than twisted pair. And so because it's a lot more expensive, we need to be able to justify why we would use it over twisted pair. And so the first one is the distance. Now, if you're in an office network where, you're in a small office or medium-sized office and you don't need to span that large of a distance, twisted pair is going to be fine, but what if you need to span multiple miles? Well, that's where this comes into play. Or what if you need to set up a wide area network? That's where fiber comes into play. So that's one of the reasons. You would use fiber if you need to span long distances. And you would use twisted pair if you need it for short distances. Now, another benefit is that we have decreased costs on our other networking equipment. So if we think about our switches and our routers, because these can span such longer distances, we don't need as many of those devices. So while we increase our costs on our fiber cable and the specific devices required to use it, we do cut down costs on our switches and routers because we can span longer distances. So that's another benefit. However, that may not offset the cost, but if you think about it from that perspective, you can offset some of the costs. So that's one of the other benefits. And then if we're thinking about security concerns and you're thinking about signal degradation, you're thinking about signal emanations and EMI and crosstalk and needing your networking to be highly reliable, well, because fiber is immune to all of those, that's another reason why we'd want to use it. We don't have to worry about EMI. We don't have to worry about signal emanations. We don't have to worry about our loss of signal over short distances because it's going to span multiple miles if we need it to. And so all this leads it to being much more reliable and much more secure. So those are other benefits. And then lastly, another benefit is that even though fiber is new, it's been around for quite some time, but it's still relatively new, and whenever you come out with a new technology, the prices are going to be higher at the beginning because there's going to be costs associated with manufacturing it. But once we get those economies of scales in place and we have many different companies and manufacturers building it, those costs are going to decrease. And so as costs decrease, you're going to see more people adopting fiber. And so those are the different reasons. So now let's go ahead and, just for fun, I decided to put a picture in of all the different types of connectors for fiber optic. And you'll notice that there's a ton of them. And I don't know what the difference is between them, but I just wanted to show you. One of the reasons why people use twisted pairs is one, it's inexpensive, and two, there's a standard in place. You'll only see that RJ45 in use, which you'll see when we talk about it more. But when you're talking about fiber optic, we have all sorts of different cables and connectors on the end. And so it's going to take time for it to be standardized, and once it does, and they pick one different type of connector or another, then the prices are going to decrease. But as of right now, there's lots of different connectors. So that's going to go ahead and conclude our introductory lecture on fiber optic cabling. If you have any questions, please let me know. If not, thanks for watching, and we'll see you at the next video.